Hello, hello, and welcome to this video. So, in this video, we are going to talk about RAII, RAII in Rust. RAII stands for Resource Acquisition is Initialization, but it is half of the story, okay? And you will see why. So, if you remember in the last video, we talked about allocating memory on heap or putting values on heap using box. So box is like the malloc or new of Java, C++. Now the question is always there that you have allocated the resource. How about cleaning up? So you see, if you take C, what we have is it is manual. You call malloc and pair it with free. Malloc, talloc, realloc, and pair it with free. In C++, what you do is you have new and then you pair it with delete. With modern C++, you have pointers like unique PTR, shared PTR, those are collected using RAII. So Rust also uses the same thing. Rust also has a manual way, just like C++. Now there is another version of this resource cleanup is Java way or Golang way, in which you have a garbage collector, and the garbage collector observes the memory allocated by the program, and then it lets them accumulate, and then finally, when it feels that it should collect the memory on the whim of the garbage collector, it wakes up, suspends every execution, all the execution, and then collects the garbage. And then we have another technique called ref counting. Right? Ref counting is done in programs in languages like Python or Perl or PHP. Now let's go over the pros and cons of all these techniques. So the C way, the manual way, gives you extreme control, but the downside is it's manual. Okay, and there's a chance that you will make a mistake while reallocating the resources. What can happen in C is that you can have objects inside objects, and there could be a deep hierarchy of objects, and if you miss one of the deallocations, then you will cause memory leak. Now, C++ balances it very well, but again, the problem is same. It allows you to do it in a manual way. Okay, so it has the same pros and cons with what C has, but at the same time, it has RAII, which is aligned with what Rust does. It's a nice way. I wouldn't call the C++ way of deallocating memory bad. It is very good. Okay. Now we come to the garbage collector way. I think it is the worst way of managing memory. Garbage collectors are bullshit. There should never be a garbage collector which suspends the program. There are two downsides of it. Okay? The first downside is that when the program is paused, all right, you can't do anything. For example, in Java, before ZGC garbage collector, the time required to collect the garbage would increase in proportion with the amount you have to scan for and collect the memory. ZGC improves this by a lot by promising constant time garbage collection. But in any case, whenever you suspend the program, it is a disaster. For systems like, for example, there's a very critical system. For example, you take high frequency trading. You can't pause the program just like that for 20 milliseconds. There are games. You can't pause the server or the client just like that for 20 milliseconds. It wouldn't work. That is one downside. The second downside is, suppose you have, say, 128 GB RAM, okay? And your program actually needs, say, 100 MB. So you allocated 100 MB, but then you need to allocate more, okay? So suppose you allocated 10 MB more, but then in practice, you are wasting probably 100 MB RAM because now you don't need that 100 MB, but garbage collector has not cleaned up. So as long as garbage collector has not cleaned up, there is always some amount of memory which is waiting to be collected. That means you are wasting precious system resources. That is the second downside of garbage collector, that your program will always consume more memory than it needs. The third problem of garbage collector is it is non-deterministic. You cannot know when the garbage collector will wake up and collect the garbage of memory. That is very bad. There are programs where you need deterministic behavior of the program, how the program will behave. And as I said, the garbage collection techniques of Java and Golang are so bad that I personally never coded in Java and Golang. It is so very bad. Java is bad for many other reasons, but it is one of the big major gripes of what I have for Java. All right. Now we come to the ref counting way. The reference counting way is nice because you can pair RAII with it. Okay. The only problem is that you see Python, Perl, and PHP are interpreted language, so they are on the slower side. Not that they are not useful; they are quite useful in their own domain. At least they are much better than Java in that regard. Java is the worst thing which has happened to computer science in last 40 years, or maybe 50 years. Anyway, that much for the personal land and the pros and cons of how we clean up the memory. Now we talk about resource acquisition is initialization. This is the Wikipedia article, and we can go and read all of it. So what I said is that resource acquisition is initialization. That is only the half side of it. If you reverse this, then what is the reverse? That cleanup initialization you can pair it with deallocation. So deallocation is resource release. So that is the second side of RAII. This RAII is only half of it. So the second side is deallocation and resource cleanup. Okay. So you can read that it is used in object-oriented, statically typed programming language to describe language behavior and so on. Resource allocation is done during object creation by the constructor, while deallocation is done by destructor and so on. RAII associated most prominently with C++, but Ada, Vala, and Rust. So these are the languages which make use of RAII. This technique was developed for exception-safe resource management in C++ during 1984 to 1989 by Stuffstrup and Andy Koenig. So the term was coined by Stuffstrup. All right. So it gives certain programs, it talks about benefits and use cases. I already talked about RAII makes it very easy to clean up the resources, and then there are limitations about cyclic referencing and so on. So which you can see when you have shared PTR and weak PTR and you use those in C++. So there is cyclically reference object. So we will not go into those details. Then we have Perl, Python. So they manage lifetime by ref counting and so on. So we can also go and read these 3 articles to understand this in more depth. And then you have certain references. We can go and look at these. For example, this is where the term is coined. So there is a lot to be read, but we will not concern ourselves with this so that our video remains small. Now I'll present the Rust example, which you have been seeing on the screen for some time. So in main function, we have a box2. We create an integer on the value is 5. Then inside a nested, we have a box3. We create another integer with value 4. Then we create a lot of boxes, about 1,000. And then over here, box2 is destroyed. And when you create this box, what it does is it allocates the box with value 3. And then it immediately goes out of scope after creation. And it's a local variable, although the data is on 8. So the scope of this variable is up to function, so it will immediately get destroyed. And at the end of program, box2 will get destroyed. So that is one program I wanted to show. The second part is that Rust allows you to perform certain cleanups which you want to do if you want to perform something. So the Rust way of creating the structure is by implementing a trait called drop. So we have not covered traits, but that is fine. The example is very small, so it shouldn't be difficult to understand. We have a struct to drop, and we implement the trait drop for this structure. And then we have a function name specifically drop, which takes a mutable self, that is the this pointer in C++ or Java, and then it just prints a line. So in general, you don't need to write this drop trait of the objects in general. In the extreme cases, you might need to do certain things for drop. For example, suppose you have certain database connections or files open, and you receive a signal for kill or term. You receive a sig term, not sig kill. You receive a sig term. You want to close those database connections. You want to close those open files and do certain cleanup. For example, you might want to write to a file so that its format remains proper. You want to make sure that the end header is there, and so things like that. So what we do is we have underscore x, and it is the structure to drop. We create a variable of that, and then we print this. So we will run both the programs. So first we will see this drop one. Okay, let me open terminal. Terminal. All right. We open for drop and we say cargo run. So you see it prints make a to drop. Okay, and note that we have not explicitly invoked the drop method, but over here when the program ends, the underscore x variable goes out of scope, and drop function is called automatically, because that's how the RAII behaves, or the destructor of Rust behaves. And then this method is this message is printed. So essentially you can do whatever cleanup you want to do here, do cleanup. You can write that code here. So that is the Rust to drop one, and now with the RAII. So there will be no output of this program because we don't print anything, but what we will do is we will do something else with this time. Okay. So valgrind is a famous memory checker. So I will invoke valgrind on the RAII target. The binary is in the folder target debug, and we perform full leak check with the valgrind. Let's run this. So you see, if you look at the leak summary, definitely lost 0, indirectly lost 0, possibly lost 0, still reachable 456 bytes, and suppressed is 0. So you see that we have 0 errors from 0 context, and we don't have leak. All right. So that's how RAII works in Rust, and it keeps the program performant. It does not create a GC port. It does not use extra memory, and it is fast. It is deterministic, and that is why it is the best way to collect memory from program. And it is not manual. At most, in certain cases, you will need to implement this drop. That's it. The things are simple, efficient, and clean. Now, one might argue that at some point we need exact control on the deallocation, that when the deallocation happens. In that case, what you have to do is you have to just keep this variable alive. Okay, if you can just keep the variable alive, the RAII won't come and picture, it won't clean up. And that's how you control the exact deletion of the object. You don't let the object go out of scope. If the object does not go out of scope, then it does not get deleted. Now, if you argue that no, the C way, the manual way gives me exact control, but you have to remember that if you want to invoke free, the object handle which is allocated on it should be alive. It should be in scope. If it is not in scope, you just can't access the handle. That would be a memory leak. So essentially, RAII gives you the exact control, just like manual way. So I think I'll stop here. In the next video, maybe I'll start talking about traits, then operator overloading and things like that. So I hope that you have enjoyed this video and my rant about Java. My advice, stay clear from Java. It's a horrible language, very bad language. It is the worst thing which has happened. So with this, I'll stop this video here, and I hope that you have found this video useful, informative, and plus some material to talk shit to Java programmers. So if you find this video useful and informative, please subscribe to the channel and like the video so that more programmers like you may access this video, because that's how YouTube algorithm works. The more likes and the more subscribes are there, the more it is recommended to other users. And sharing is good. In general, sharing is good. If you have good stuff, you share it. Okay, that increases the joy. There is a joy in sharing. So thanks a lot for watching. Happy programming.